All right, let's review some integrals, all right? So we learned that an integral is the area under curve. So here we have a curve, and the function is 9 minus 1/4 x squared. We want to find the right-hand sum. So that would be finding the sum at these points here. So right-hand sum means we're using the right hand of each of these. So a good way to go with these is to go ahead and take a moment, and since we're going to be doing right hand and left hand, also known as upper sum and lower sum, but more generally for the AP test, we'll have right hand and left hand. So let's find at each of these values 2, 3, 4. What do we got? 5 and 6. All right. So we're using 4 subintervals, so that's on the left. Let's find the value of f at each of these here. So we'll evaluate this here. So we got at 2, plug in 2, we've got 4, that's 1, that's 8. At 3, that's going to be 27/4. And at 4, we get 5, and plug in 5, we get 11/4. And finally at 6, we get 0. So we found these functions here. Now the right-hand sum is going to be the area using the right-hand point. So we say the integral from 2 to 4 of 9 minus 1/4. So this is approximately, and we're going to find some areas, which are length times width. And in each of the widths are 1. So we got 1 times f of, and we're starting at 3 in this case. 1 times f of 3 times 1 times f of 4 plus 1 times f of 5 all the way up to f of 6. And since we've already taken time to compute those, we can just use our little table, use our values over here, and we get, this is really just f of 3, which is 27/4, f of 4, which is, let's write that in fourths, 20/4. Instead of 5 there. And we got 11/4 and 0/4. And adding all that up, we get, 31/58/4. And let's see, 2 goes into there, yeah? How about 29/2? That'll do. All right. Well, the left-hand sum, so this is going to be using the left-hand points. So the left-hand side of each rectangle is at f of 2, f of 3, f of 4, and f of 5 for this rectangle. Okay, so we want the integral here, from 2 to 4 of 9 minus 1/4 x squared. Right, that's a squared. So this looks like a 7 here. And that's going to be dx. And again, we're going to just use the right-hand points. So the right-hand points are going to give us 1 times f of 2 in this case, because that's the first, I'm sorry, left-hand points. Left-hand points. F of 3, f of 4, and f of 5. And we'll stop there. Not going all the way to 6 because we're just using the left-hand side. All right. And so looking at our table, we've already computed those. And they're all times 1. So that's nice. We don't have to really do that multiplication. That's just going to be 8, which actually everything's in fourths. So let's go ahead and write that as 32/4, 27/4. 20/4 and 11/4. Okay. Let's see. These ones actually add up to 58/4. I already know that because that's what we did above. So 58 and 32 gives us 60/94. Okay. So that's going to be 90/4. Okay. And let's see. That's 45/2. 22.5. All right. The trapezoidal sum. All right, so the trapezoid, remember the area for a trapezoid is 1/2 times the sum of the bases. It's the average of the bases times the height. Okay, so our integral from 2 to 6 of 9 minus 1/4 x squared dx. Okay, so for each of these, we got 1/2 times the two bases, in other words, the left and right hand side, okay, times the height. Well, the height of each of these, let's come over here to our, okay, so we're talking about this trapezoid here, and the height of this trapezoid is just the 1. Okay, so the height is 1, okay, and then the A and the B are the two sides. Okay, this will be A and B there, all right? The two bases. So the bases will be those two, the two F values, all right? And then the 1/2 can factor out. So we have this. If we write them all out, we get 1/2 times F of 2 plus F of 3 and times 1. I'll fast forward here. So we could write it all out like this. However, I would not recommend that. If you notice, we can factor out 1/2 because there's 1/2 in all of them. And we could factor out the height, which is times 1. So if we kind of pull those out, what we're left with is F of 2 plus 2 F of 3s plus 2 F of 4s plus 2 F of 5s plus an F of 6. All right? So that's all we really need. So just half of that sum. Okay? So that sum ends up being the average of the left and right hand sums. All right? Because the F2 plus F3 plus F4 plus F5, that's the left-hand sum. And then 3, 4, 5, 6, that's the right-hand sum. So it's just the average of those. So the 1/2 plus, what are our sums again? 29 halves and 45 halves. All right, so we already found all those, so let's just use that. All right, 29 halves plus 45 halves. All right, and so we got, what, 1/2 of 74 halves, or 1/2 of 37, so that's going to be 37 halves. All right, there you have it. All right, let's cruise along. Next one, we want to write a summation for the approximate area here between the graphs of y equals 9 minus 1/4 x squared. So y minus 1/4 x squared goes like this. There's half of it right up here. Okay, it's going to intersect at 6 and negative 6. So we want to find this whole thing. So the twist here is we need to integrate this from negative 6 to 6. So we're going to find the integral from negative 6 to 6 of 9 minus 1/4 x squared dx. That's where we're headed. Okay, using the formal definition. This is the, I'm sorry, let's see. This says using 20 rectangles. Not using the formal definition yet, but using 20 rectangles. So we have the sum from I equals 1 to 20. And then we're finding rectangles. So the width of this is 12, because from negative 6 to 6 is 12 divided by 20. So that's the width of each rectangle. And then we need f of x, which is 9 minus 1/4 x squared. But the x is starting at negative 6 and going to, by increments of 12/20. And we need an I there. All right? So, kind of ugly there. but that's what we got, and we're going to go use our calculator to do that. And I might clean it up a little bit here. 12/20ths is, 3/4, and I'm going to move that out. Let's just move that out. 3/4. All right. And the sum of 1 to 20. That makes it a little bit cleaner. Don't want to do much simplifying here. All right. So let's go to calculator, see what we can get. So plugging that into the calculator, letting it do all the hard work, we get 3591/40 or 89.775. All right. So let's get that out of there. 89.775. All right. Which kind of checking to see if that makes sense. If we look at this here, this triangle right here has an area of 1/2 times 6 times 9, which is about 27. Okay, so it's going to be a little bit more, maybe 35. So the real area is about 70, so this is an overestimate. All right? All right. So cruising along here, let's simplify this summation here. All right. First thing we want to do is we want to distribute this. Okay, I equals 0 to n. And if we distribute, we get 3i squared. And then we're going to have minus 6 plus 1. That'll be minus 5i. And then minus 2. All right. Now, our formulas that we've memorized are actually from 1. So a little twist here, and I don't think you would see this on a test. That would be kind of mean if it does. We'll usually go from 1. So we need to plug in 0 and figure out what the 0 term is. If you plug in 0 here, you get 0, 3 times 0 minus 5 times 0 minus 2. And so you get a negative 2. Okay, so because that's 0, which probably was meant to be 1, but it's not, so it's a good lesson here. Okay, now with the 0 term is negative 2, and then we can do our sum, 3i squared minus 5i minus 2. Okay, now remember we can break this up into, there you go. We can break this up into 3 parts and just treat these sums differently. Okay, we don't necessarily need to write that out, but we're going to have the first term. Well, first of all, we got this negative 2 that we don't want to forget here. All right, so let's come on up here. We've got negative 2, and then plus 3 times I squared from 1 to n is going to be n times n plus 1 times 2n plus 1 all over 6. And then minus 5. I is going to become n times n plus 1 all over 2. And then minus 2 times n. All right? All right, and simplifying this, a little bit of algebra going on here. We have 1/2. After you multiply that out, you're going to get 2n squared plus, actually cubed, 3n squared plus n. And you're going to get minus 5/2 times n squared plus n. And minus 2n. Okay. That's that. And then a little simplifying here. We're going to end up with n cubed and minus n squared minus 4n. Okay. All right. So, moving on now. Let's look at some integrals. Okay, so here we're going to sketch a graph that's represented. Use a limit definition to evaluate the integral, and then see if we can use the FTC to evaluate it as well. All right, so if we sketch a graph here, 2x minus or plus 3, that's just a line. Okay, so 2x plus 3, 1, 2, 3, and then a slope of 2. All right, we're going to evaluate it for 1, 2, 3. Okay, so we just got a hexagon here. And so to get the directions say this, B, use the limit definition of the integral to evaluate, okay? So the limit definition, or the formal definition, is the limit as n goes to infinity of the sum of I equals 1 to n. All right, and our delta x is 3 minus 0, which is 3. And our CI value is going to be 3 over n. And 0 plus 3 over n. All right, okay. So we have the width, which is 3 over n, because the whole width is 3, times the function at our c value, so that's 2 times 3 over n, I, plus 3. All right, now we're going to evaluate this using what we know about summations. So, this, by the way, needs to be there. All right, so the limit as n goes to infinity of I equals 1 to n. Simplifying this, we're going to get a 9 over n over there. And we got a 9/18 over n squared I. And so this is a limit as n goes to infinity of I equals 1 to n. Let's go ahead and figure this. Okay, we can do this sum. And we know we're talking 18 over n squared times n plus 1 all over 2, plus a constant 9 over n times n. Okay, and we'll clean this up and figure out the limit here. So this is just 9, and this is going to be 18n squared plus 18n all over 2n squared. Okay, and as n goes to infinity, the small term doesn't count because it's only power of n, and we end up with 18 over 2, which is 9. So this is 9 plus 9, which is 18. All right, and then we can use the fundamental theorem of calculus to check that. So if we say the integral of 0 to 3, it's going to give us x squared if we take the antiderivative, 3x, and we're going to evaluate that from 0 to 3. And so that equals 3 squared plus 3 times 3 minus, we're going to plug in 0. We're using FTC1 here. X is 0. So that second part just becomes 0 altogether, and this is 18. And that's the same thing, so it checks. All right. One more here. This one's going to be a little more work because of the squared there. All right. So 10 minus x squared. So this is, looks like this. Parabola goes up to 10. Okay. And so we're going to have the limit as n goes to infinity of the sum I equals 1 to n. And our width is 3, so we're going to have 3 over n. And our height is going to be 10 minus. And we're going to have a starting value of 1 plus 3 over ni. Okay, so it's going to take a little bit of algebra to calculate this here. But we can do that. Let's just simplify the sum and then we'll come back to that limit. All right, don't forget the limit though. So we're going to have 3 over n times 10 minus, and we've got 1 plus 6 over ni plus 9 over n squared I squared. And that's good. So this 3 over n is a constant. We'll just think of that coming out here. And so we have 3 over n times, and this is going to be 10 minus 1, which is 9. And so we're going to have 9n plus, we have, this is all going to be negative. So that's actually going to be a minus because we're going to distribute this negative here. Okay. And so that's going to be minus 6 over n, and when we sum it, the I is going to be n times n plus 1 all over 2. Okay. Plus, we've got 9 over n squared. Actually, again, that's a minus because we've got to distribute that negative. 9 over n squared, and that's going to be times n plus 1 times 2n plus 1 all over 6. Okay. So that's going to become that. We're almost there, all right? We're going to distribute that. Now, let's plug this back into the limit and kind of distribute at the same time, all right? So this is going to go back. We've got the limit as n goes to infinity. So we've kind of simplified the summation, okay? At the limit, so we're going to distribute this to each of these here, all right? And so this is going to be 3 over n times 9. That's just going to be a 27. 27. And then this n times this n is going to be an n squared. Okay. This is going to cancel here and leave 3. Okay. And so it's going to be 3n squared over n. We don't care about these smaller terms that we're going to get. So it's just going to be this 3 over n times this 3. So that's going to be 9. We're going to have n squared on top, n squared on bottom. We don't care about the smaller terms because of the limit. At the limit, those small terms don't matter. Then we got 3 over n times all this craziness. Let's simplify. And that's going to give us 9, actually 18n cubed over n cubed. All right, in the end, this comes out to be 27 minus 9. And that is simply 9. And there's our area. All right? Okay. So we've got an area of 9. And if we compute that with FTC1, we get this. The antiderivative here. And we get this. And let's substitute that. And that's going to give us 30. And this will be minus 63 thirds. Okay. And that's 30 minus 21, which is 9. Okay. It agrees.